This is the University of Washington's Math 120 pre-calculus course. We're looking at the 7th question from the winter 2016 final exam. This question is about linear to linear rational functions. In particular, we're asked to consider Frank, who's running for office, and his percentage of the votes earned is a function of his advertising spending. In particular, if Frank spends $1 million on advertising, he'll earn 34% of the vote. If he spends $4 million on advertising, he'll earn 49% of the vote. And we're given that as spending increases, his vote share will approach, but never quite reach, 65%. So we're asked to help Frank win the election by choosing how much to spend on advertising. In particular, Frank wants to know how much to spend on advertising to predict that he will earn 55% of the vote. So if you haven't already, go ahead and pause the video now and see if you can make sense of this on your own. Okay, let's dive in. We're asked to model a rational function, in particular a linear to linear rational function. A rational function is simply a ratio of functions, and a linear to linear rational function is a ratio of linear functions. So initially, when we're trying to model a rational function, we're looking for 4 coefficients, a, b, c, and d, to make sense of our linear function in the numerator and our linear function in the denominator. I hope you recall that in modeling linear to linear rational functions, we really only need to deal with 3 variables. In particular, it suffices to look at functions of this form. Here, we've reduced our 4 variables of a, b, c, and d to only 3 variables of j, k, and m. In particular, the way to do this is to simply factor out a c out of each of these 4 variables, and then rename your variables as such. So we're looking to find j, k, and m using the data we have. In particular, we're given 3 data points, these 2 explicit points, and this information about the asymptote. Now, linear to linear rational functions all look more or less like this. This drawing is a little bit poor. In particular, these values should agree. Let me take another stab at this. So we have a better drawing of our typical linear to linear rational function. Notice what happens to this function as x gets really, really, really large. Say we have x being 1 billion. This k and this m become relatively insignificant as this jx and this x become quite large. And in particular, as x gets really, really, really large, this k and this m become essentially insignificant. So if we imagine x as a very, very large number, this k and this m become insignificant, and we can see that the value of f of x will simply be j. The k and m are insignificant, the x's essentially cancel, and we're left with j. So in particular, since we know that Frank's vote share will approach 65%, we know this value of j to be 0.65. Now, we simply have 2 unknowns, k and m, and 2 explicit data points. We can do what we always do, plug in our 2 points, generate a system of 2 equations, solve our system of 2 equations for k and m. Let me just rewrite these with x plugged in here. So this is my first equation now. Okay, so now I have my 2 equations, and I need to solve the system of equations for k and m. I think I'll probably clear the fractions and the decimals. I'll clear the fractions by multiplying by 1 plus m and 4 plus m, respectively. And I'll clear the fraction or the decimals by multiplying by 100 on each. So I'll rewrite my two equations after that change. So here's my equation 1 and my equation 2. Now, again, I will still solve this with elimination, and I still will do the same thing I did before of just subtracting. I'll start from this one and subtract this one away from it. And I'll solve for m here. Okay, so I have m. I checked the arithmetic. This works. I need to solve for k. 34 times 2.2. So let's one more time combine these into a single equation and see whether it actually models our data. And let's do some computation to check. I'm happy with the value of f of 1, and I'm happy with the value of f of 4. Whew. Okay, so now I have a function f here. We can now do what the question actually asked us to do, which was to find a amount of advertising spending that would correspond with a vote percentage of 55%. So we simply need to set up this equation and solve for a. From here, this is purely algebraic manipulation. I'll grab a calculator for this. So I have computed a value for a. Let me check that it agrees with my intuition. 1 million was 34%. An extra $3 million got a value of an extra 15% of the vote. We're trying to get from there another 6% of the vote, and it takes another $3.5 million. That seems totally reasonable to me, in particular, especially since you can see on the graph that the contribution of the first $3 million is going to be bigger than the contribution of the next $3 million. So we have that Frank should spend $7.72 million in order to secure 55% of the vote.